Hello world, Brandon with FastDataScience.ai, and welcome to another episode of This Week in AI. So although I am having a bad hair day, hence the hat, I'm having a really good data science day. I've got a bunch of things that I want to share with you today, some really interesting research that's happening in the field. And today we're actually going to tackle three really cool trends that are being reported on this week in AI, the show where I bring you all the latest news. Well, not all of it. Actually, I curate it. I bring you some of the major headlines in the latest news in artificial intelligence, machine learning, and data science. And so today, on today's show, we are going to take a look at DALL-E 2's coming out party. Yep, DALL-E 2. We'll talk a little bit about what that is if you don't already know. It's all over the news. We're also going to talk a little bit about how machine learning is getting astronomical. We'll look to the stars. Finally, we'll talk a little bit about some of the research trends that are coming out of the fascinating minds of the DeepMind group. And so we'll take a look at some of the top research areas that team is reporting on and talk about some of the trends that we may be seeing more and more of as companies figure out how to monetize all the cool research that's happening with DeepMind. But before we do, because Dolly has been just everywhere lately, so for those of you who don't know, Dolly 2 is the second generation of Dolly 1. Dolly is a machine learning model, an artificial intelligence model. It's multimodal, and what's really cool about Dolly is its ability to use descriptions, that is language descriptions, text-based descriptions, in order to generate images. So it's a multimodal, artificially intelligent model. And what's really cool is that it does it with pretty high degree of accuracy and also a high degree of resolution. So the images are really high quality, not just really interesting, depending on what you put in. So that's got me really just kind of fascinated. And I think you've heard me talk about this before, but I stumbled across Craiyon, CRAIYON.com, where you can generate your own images. And so I was playing with crayons today, and I have been all week. And so I wanted to share some of my findings. So I asked Crayon, please generate for me a new image for this show, maybe a new theme. So Crayon is based off a miniature version of Dolly. Used to be called Dolly Mini, now it's called Crayon. And so here's what happened when I put in This Week in AI. Nothing groundbreaking. And I'm not even really too sure where the word week gets incorporated in here. Okay, so then I kept playing and I asked Crayon to develop something for fast data science. And what did we get? Very similar. Yeah, maybe the one over here in the top right is kind of interesting. I don't know. All right, Crayon's got a long way to go, but Dolly 2 doesn't. So let's go ahead and get after today. Today is July 22nd, 2022. Wow. It's crazy that we're already over halfway through 2022. But let's talk a little bit about Dolly 2's coming out party. So OpenAI, the company that developed the Dolly multimodal foundational image to text to image model, is coming out. It's becoming even more generally available than it was before you had to sort of beg and plead OpenAI to let you use Dolly for some use case that you may have had, but today they have announced, well, not today, but recently, that Dolly 2 is becoming more generally available. There are a number of free limited uses that we can get access to as the general public in order to experiment, maybe even utilize the tool or prove out some possible product. But what's really interesting about this coming out party is it should become abundantly clear that there are a lot of potential downsides to Dolly 2. And what we've learned from these large language models, these foundational models that are trained essentially on the internet, is that not only do they learn really sophisticated responses to prompts, but they also learn some of our human biases and some of our human proclivities that aren't necessarily the best things about us. So this particular coming out party is where OpenAI has addressed or tried to address some of those very issues. One of the issues is showing greater diversity. In my experimentation with Crayon, I was curious. I typed in data scientist. I think I did it in a vacuum because I was making a funny pun. See my posts on social media if you want to see where that pun went. But what returned was just a lot of white dudes. And so while Crayon kind of was emulating some of the problems of those models, DALL-E 2 is a way, or at least OpenAI has attempted to try and overcome some of those issues by influencing the model to produce more diverse representations of descriptions, particularly, I think, probably around sensitive social groups. In addition, DALL-E 2 comes with a very strict policy around only creating G-rated images. Okay, well, now that's got me thinking. And also with a stipulation that you can't create images that will do harm to someone, be they a public figure or a private figure. It doesn't matter. Images can do no harm or do very, very, very little sort of objective harm. I think that's a little subjective, but it'll be interesting to see how this gets rolled out, what kinds of products people build on top of it. It's kind of exciting, and they're actually starting to allow things to come into the world. The problem is that it's not all free, and so you do have to pay a subscription fee for how many times you want to use the service. Okay, moving right along into the next headline. So we're going to tackle how machine learning gets astronomical, how artificial intelligence is changing astronomy. Machine learning has become an essential piece of an astronomer's toolkit. Okay, so this is cool. I learned a lot in reading this article about thinking about how machine learning can be used in different contexts to answer research questions. Actually, this has become something I've become even more, I think, attuned to, as I've seen some really creative applications of using machine learning models in the way that they're trained to learn things about real biological systems, or in this case, physical systems, astronomical bodies, in the way that they relate. So here's the deal. Machine learning gets astronomical. How? Astronomy deals, okay, in petabytes of data, not terabytes. So what's a petabyte? A petabyte is 1,000 terabytes, or 1,000,000 gigabytes, or 1,000,000,000 megabytes. Okay, so a petabyte is a ton of data, and astronomers are really used to extremely large databases that are on the order of petabytes because we've been taking pictures of the sky for many, many, many years. And so all that builds up into fairly large files that, take up a lot of disk space. What's really cool about how they're using machine learning is to understand the sky at a much greater scale. And so what do I mean by that? Well, one simple application here that kind of dawned on me as I was reading this was that they essentially take samples of the known sky where we've identified things, new planets, perhaps black holes, or interesting phenomena in the night sky. And what they do with that is use it as a training set. They train a model on what we know about the sky, and then they apply it to new pictures of the sky that we don't necessarily, haven't had the time necessarily look at, to see if the model identifies those similar anomalies or phenomena in those other areas of the sky, so we can quickly scale our search of phenomena in the sky. In addition to that, what's also really cool is they are using generative models. And one idea that came to my mind was, I wonder if we could build a generative model to generate a representation of the sky and perhaps use that to test hypotheses. So if we can generate accurate representations of the sky that we know about, can we also generate how that sky might look in other contexts and help us answer some really cool astronomy questions? And this is where the limits of my astronomical knowledge end. Okay, so let's go ahead and jump to the last article of the show. The last article, what caught my eye? Yes, it's another Crayon image. This time it's me entering DeepMind. Now these are cooler images than the Fast Data Science one or the This Week in AI one that Crayon generated. I love these. These are super psychedelic, really trippy looking. And so they definitely look like we're getting deep in the mind. And so these are some fun images. Yeah, play with these in other scenarios would be really fun. But what is it about DeepMind that I want to talk about? They were presenting some research this year at ICML. What is ICML? That is the International Conference on Machine Learning. And so here are DeepMind's top research areas that they're giving talks on at this conference. all of it is around the theme of creating artificially intelligent models or machine learning models that generalize more effectively to lots of different tasks, scenarios, contexts, whatever they may be. Um, this is sort of, I think, skirting around another very popular conversation in the field, which is, sort of creating consciousness in AI, right? It's a separate issue. Generalizable AI is one thing, and there's a probably pretty good debate happening right now on whether or not you can have a truly generalizable artificially intelligent system that isn't also artificially conscious. But, again, philosophical debates ensue. Let's talk more practically about what's happening at DeepMind. DeepMind is talking about creating efficient reinforcement that is focused on generalizable things. So what helps create more generalizability in reinforcement learning? Reinforcement learning, remember, is the process through which we train a model to learn what actions to associate with a particular scenario or situation or environment. In other words, learn how to, for example, play a game. And so what they're interested in really investigating is trying to improve the use of transfer learning, so using models that have been trained in other contexts in order to inform new models trained in new contexts, and using zero-shot learning and improving the methods of zero-shot learning. Zero-shot learning is a process through which we build a model that uses one or two examples of a situation and can use that to essentially learn all kinds of related situations so that it generalizes more quickly. You need less data. So there's a lot of research happening on how to improve zero-shot learning, particularly in the context of reinforcement models. Also improving the agent's generalized policy. So a policy in reinforcement learning is simply the association of an action to a setting or a scenario or a stimulus or whatever it is. It's just the association of those two things. But turns out that creating those associations and learning them is very complicated. And so we are looking at ways through which you can create generalized policies, policies that help you apply actions to lots of different contexts. And then finally, dealing with this issue of memory. So these reinforcement systems don't necessarily have inherent memory. And so it may be an opportunity, and I don't know, this is something, again, gets the limits of my machine learning knowledge, but I would venture to guess somebody is probably looking at trying to figure out how to combine a reinforcement architecture with maybe like a transformer-based architecture. I don't know if it's possible. I've only experimented a very little bit with transformers, and I really haven't done anything with reinforcement models at all. So it's a hypothesis. Maybe it's a good one, maybe it's a bad one. But I would venture to guess someone's at least thinking about it. If I am, someone else certainly is. Finally, well, not finally, there's two more other research areas. So language models, they become very popular. They're all the rage right now, especially these large language models, which are being called foundational models. The question really comes around whether or not we can improve the efficiency of training those models. These models are massive. Just downloading some examples of those models or smaller versions of them still require, 20, 30, 40 gigabytes of RAM to be able to load into memory and score and develop new sequences and things like that. So there's a real question around how do you improve the efficiencies of these language models while retaining their sophistication. There are also lots of questions happening around the limitations of what's being called short memory. So transfer learning is really good at remembering things. So it remembers important features of a sequence so that you know how to apply responses or predicting next words in a sequence that you're producing because you remembered something important. And it knows how to assign importance. It has what's called attention. It can attend to different things that may be important in a given sequence, so it knows how to respond to that sequence. The problem is the number of sequences or the number of tokens in a sequence are limited. And so that means that essentially these transformer-based models, language models, have a limitation in their short-term memory. I've always wondered about whether or not there is an opportunity to think about a long-term memory store that these language models can benefit from. Again, gets at the limits of my knowledge here, just a hypothesis, but it could be really cool. What comes of this is also trying to understand how these models forget important features when they're trained on new data. So just because we know that something is worth attending to, it's important in a sequence. In one training context, we might learn a different training context that kind of teaches us to ignore that thing that used to be important because now something else is. We don't really understand how that works, and so there's a lot of research into understanding how that forgetting sort of happens. But it's a very interesting question, and I think it may help us really understand how to improve the memory of these systems. And again, maybe there is some long-term memory mechanism that can interact with these models to improve their generalizability. Finally, algorithmic reasoning. This is another area of research that DeepMind talked about. And this is where we get into a little bit of a semantic, I think, confusion. Algorithms are often used to describe lots of things, but traditionally, an algorithm is a very specific set of rules that lead you always to the same outcome. And so algorithms have their own meaning in certain disciplines. And so essentially what's happening, and algorithms are really important for like software programming and computer science. And there's really a limited number of algorithms out there that have been extremely useful in solving all kinds of electrical problems, if you will, problems that deal with how chips interact to essentially run like, so for example, the same algorithm or same concept, the same general algorithm operates a microwave that operates a pacemaker. Sure, their implementation is different, but it's fundamentally built off the same algorithm. So the idea is, can we use deep learning and some of these foundational models maybe to start to learn how to use train models to use algorithms to help them make decisions? That's really interesting. Again, the confusion is we talk about some of these machine learning models as algorithms, and that's a little bit of a misnomer because, as I mentioned, algorithms have a very specific meaning, especially in certain contexts or certain disciplines. And this is one where we're trying to take and apply the limited set of algorithms that have had tremendous utility in software engineering and apply it to deep learning in order to generalize the ability of those deep learning models to solve new problems. Okay, thank you so much for attending with me. Those are the wrong links. I forgot to put the links. I'll put the right links in the comments. Share, do all the things that you do. Hopefully you got some good ideas today as well, because I certainly have some research questions I'm going to be looking into. But have a wonderful weekend, and I hope to see you in the next episode of This Week in AI. Bye, everybody.